Hey there. If you remember in class, what we did was we looked at Wikipedia, found a table that we wanted to visualize. We used Python to scrape the whole information from the web page and then highlight one of the tables and then read into Python exactly the data that's in that table, which represented the world population from 1950 to 2015. So from this information, we saw that the population seemed to grow at a constant rate. And so what we'd like to do is we'd like to simulate that growth of the population using Python. And our goal for today is going to be to create this simple population growth model um, that works with the data that we imported to create a simulation that will give us data, give us a line here that approximates what the population of the world was over this time period. So in order to do that, we need to be able to access the information in our simulation, so in our table, to come up with what the slope of this line is and use that to be able to simulate the annual growth of the population. So let's first talk about this mathematically. If we're going to calculate the average uh, population increase per year, what we need to do is we need to calculate the change in the population divided by the change in time. And so in terms of the data that we have, that means calculating the population at time, at time 1950. Let's actually choose y2 instead of y1. The population at 2015 minus the population at time 1950 divided by 2015 minus 1950. So this will be our annual growth amount. That will be the slope of this line. And so once we have the annual growth, then the philosophy in our simulation is going to be start with the population at 1950 and then use the inductive step that says the population at time t plus 1 is going to be equal to the population at time t plus this annual growth. So that's the basic premise here, that if we know what the population is at 1950, then we can calculate the population at 1951 by adding this constant to it. And then we can use the population at 1951 to calculate the population at 1952 by adding that same constant c. All right, so that's the philosophy behind the setup. And so now we need to figure out how to put this into code. All right, so we're going to head over to Python shortly, but before we do that, I want to highlight a couple of the things that we're going to be seeing here. The key piece of information that we're going to see here that is new is that when table 2 was imported, it is now a data frame object. And then when we extracted the column from the table, and then census is a series object. So it's similar, it's the idea of what a time series or a sweep series has been built upon. It's slightly different in that we're going to use the precise terminology of accessing information from the series object. So this census, to get the first entry from census, and I guess I'm not asking for the first entry from census. Let me strike that. What I really want to say is to get the first, to know what that first year is. To get the first year that appears in census, we use this way to do this. We write census dot index of 0. All right, and so what this is doing is if you remember, we have the census data. It has 1950, 1951, all the way up to 2015, and then it has the populations at these places. So I think I have some of that information here. I mean, let's just say 2.5 and then 7.2. I don't know exactly. Let's just approximate that. So what we need to do is we need to extract this number 1950 and this number 2015. And so this column that everything is based on in terms of this the array of data, this is the index. And so what we're reading off here, the 0 tells us we want the first index of the list. So if you think about it, census of 0 is asking us what's the 0 at what's the value at time 0. Well, we don't have time 0, we have time 1950. So that's the difference here. We don't actually want to know what the census is at 0. We want to know what's that first time value, and then we can use that time value to extract what the first value of the census is. So this gives the first index, but then when we do, so let's define that to be time 0. So we'll use t underscore 0 to be that initial census value. And then our initial population is going to be what census is at that initial time. Okay, so that's what the difference is here between these two lines of code. The first one figures out what that first time is by extracting it from this list. And then when we know what the initial time is, we can plug it in and figure out what the first value is for the census. One fun, I guess this is like a fun little trick about how to index things, right? We use the numbers 0, 1, 2, 3 to correspond to the first, second, third, fourth entry of a list because we're computer scientists. But if we wanted to access the last entry of the list, you'd have to know how many entries there are in the list. But we have this really cool shorthand that says let's pretend that the last entry kind of circles around to before the first entry. In that case, we can index this last entry instead of by entry number 65 or 66. We're going to call it entry -1 to correspond to the first entry at the end of the list. So an index of -1 corresponds to the last entry of the list. So when we ask for a census index, dot index bracket -1, it feels like we're trying to go back in time by a unit, but what that really should, what we've used this shortcut to represent going to the end of the list and starting to count backwards. So we could talk about -1, -2, -3, and that would be either the last or the second to last or the third to last entry of the list. All right, and so this is going to be our end time. T end is going to be census index. And similarly, we can calculate P end to be equal to census bracket T end. All right, and so now this annual change, the annual growth, we can calculate. We have all the tools that we need. It's going to be equal to, P end minus P0 divided by T end minus T0. All right, so now let's go see that in action. All right, so we're here in the Chapter 5 notebook in the section Modeling Population Growth. Here we define T0 to be census index 0, and that's indeed to 1950. T end is census, the last date, which is 2016. And so how many years is that? That's 66 years, so T end minus T naught. And then what about the population? So the population at time 0 is census of T0, and population at the end is census of T end. And so what we get is the total amount of growth is about 4.7 million. So over 66 years, we've grown 4.76 billion people, excuse me. And that gives us an annual growth of about 72 million people per year. That's a lot of people. All right, so now we put this into our simulation. So we create a time series to keep track of this population. Results of the time is going to correspond to how many people our simulation suggests that there should be at that time period. So we define results. We then define the first value of the results. So this is our first step, to be equal to P naught. And so that's what our table looks like. This is our time series before we do any for loops. And then we create a for loop that will run through all the different steps from time 1950. Oh look, you hover over it, it tells you up to 2016. And it calculates, it says, okay, what is the population at 1951? Well, it's the population at 1950 plus this annual growth rate. We run that, and when we do that, let's actually show the results again. And you can see here, it starts off at 1950, and then it projects all the way to 2016. Here, recognize here this range command. Remember, we saw this back before. This is going to start off with 1950, and it's going to go up to, but not including, 2016. So our first piece of data, that was the thing we put in at the beginning, and then it calculates the value for 1951 up to 2016, because that's results of 2015 plus 1. Okay, and then we can put those all together in the same plot. Something hiding underneath here that might be useful to think about is that plot estimates, this function that we defined before, what it's really doing is just putting in 2 more plot statements after results dot plot. So it's plotting results, it's plotting census, and it's plotting UN all at the same time. There's even 2 different decorate commands, one of which is giving us the axes labels, and this one is giving us the title. So all that information just is one after the other after the other. Once it gets to the end of this command, it dumps it out into a pretty chart that you can use for whatever you want. All right, so let's stop there for now, and the next video we'll talk about how do you set this up to work for any different growth model that we might want. All right, see you later.